Today we're doing section 5.4, day 2, and again we're still using sum to product and product to sum formulas, but now we're just going to apply it to verifying identities. So for our first example, you're trying to verify the following identity. So the problem is cosine of 3x minus cosine of 5x all over sine of 3x plus sine of 5x. And you're trying to prove that this is all equal to tangent of x. So the way we go about this is we're going to use our sum to product formulas. So here I have a cosine minus cosine, so I would select the cosine minus cosine formula. And here's our alpha, and there's our beta. And again, we just fill our values into the formula. So I have -2 sine of a 3x minus 5x all over 2 times sine of, actually, you know what, that should be plus. This one should be 3x minus 5x all over 2. And then in the denominator, I'm going to use the sine plus sine formula. So this one says 2 sine of alpha plus beta. So I have 3x plus 5x all over 2 times cosine of alpha minus beta all over 2. And now I need to clean this up, obviously. So this right here, I'm just going to kind of pull this off to the side real quick. So 3x plus 5x will be 8x divided by 2. So that will become 4x. And this right here, we'll have 3x minus 5x would be a -2x divided by 2, which will be -x. So to kind of go back and to fill this into the formula, I'm now at -2 sine of 4x sine of a -x all over 2 sine of 4x over cosine of a -x. And again, now I need to simplify from here. So these 2's out front are going to cancel. So these 2's are going to be gone. This sine of 4x is going to be gone. And now I'm left with the negative out front times the sine of -x. And I know sine of -x, the negative goes out front. And in the denominator, cosine of a -x, I know the cosine goes, the negative goes away, gets dropped. And here I have 2 negatives, and 2 negatives will make a positive, so they're canceling out. And I know sine divided by cosine is tangent. And so we can see that I've proved my identity because it's verified. I've got tangent. So let's try another one. So here we're going to go back to one where we have a graph and we have an example that we're trying to prove it equal to. So here is my picture. 2, 3, 4, and we'll assume this is 2 pi. And on our picture, it looks like this. And the problem that we're trying to verify this with is that y equals sine of x plus sine of 3x all over 2 sine of 2x. So again, the first step that we have to do in this problem is that I have to figure out what my trig function is, so I know what I'm proving it equal to. So I know that this trig function is a cosine of x. So I'm trying to prove that this whole identity is equal to cosine of x. So here we're using the sum to product formulas. And x is my alpha, 3x is my beta. So I'm using the sine plus sine formula. So I'm going to start with 2 sine of alpha plus beta, so x plus 3x all over 2, times cosine of x minus 3x all over 2. And in the bottom, I have 2 sine of 2x. So from here, we're going to do some adding and simplify the top. So now I'm at 2 sine. In the numerator, I'm going to get 4x, and 4x divided by 2 will leave me with 2x. Then I'll have cosine x minus 3x is negative 2x, divided by 2 is negative x, all over 2 sine of 2x. And again, I need to simplify what I can. So these 2's are going to cancel out, and the sine of 2x is going to cancel out. And now I'm left with cosine of a negative x. And I know that cosine of a negative x, that the negative goes away. So I have cosine of x. And that is what I was trying to prove it equal to. So at this point, we can say my identity is verified. So that's all for today. We'll pick up with this tomorrow.